And we're back again with another chemistry video. Hello guys. I'm just gonna do a real quick recap from yesterday, and wasn't my best attempt at a video, but hey, we're learning here. So, you all should have done the assignment where you have to look at a solid, and you have to find out the melting point, the boiling point, forces between the particles, what type of solid it is, all that great chemistry stuff. We're going to start off today with a fantastic meme. This comes from the chemistry memes subreddit. Yes, there is a subreddit for chemistry memes, and it is filled with stuff you probably will not understand. But some of them are gold, like this one. And I had a hearty chuckle at it. Alright, so we looked at ionic solids yesterday, and we'll be finishing that off today. So they look like this. It's like a 3D shape with all the ions connected to each other, and they're just held together like magnets is the best way to describe it. There are lines here, you can see the lines. There are not actually any lines in it, they're just all balls stuck together. And we looked at this yesterday. Solids, again, when they melt, when you have ice in a drink, the drink stays at 0 degrees, even though it's hot outside, as long as there's still ice in the liquid. That's because all the heat that's going into your drink isn't heating up the drink, it's using it to melt the ice, breaking those bonds between the molecules. This is a much better representation of what an ionic solid looks like. There's none of those lines. It is just ions stuck together. Again, it takes energy in the form of heat to break bonds between molecules. Cool. And when bonds are formed, energy is released as heat. So actually when you freeze ice in the freezer, you put some water in the freezer and you make ice, you're heating up your freezer when the water freezes. It's whack. Alright, this is actually your task for today, and if you go into the Google Classroom, you'll see that there's a Google Doc where you can go on this and you can write answers. Ignore this first bit, you should be able to do this. In solids, particles are held together and they're in fixed positions. They're close together in fixed positions. Liquids, particles are free to move, but they're still like tied together. Gases are far apart, and they move in all directions. They move randomly in all directions. Solids have a fixed shape. Liquids take the shape of their container, and gases expand to fill their container. You should all know this by now, and so you just need to write answers for these 1, 2, 3 questions in the Google Doc, which is in the Google Classroom. Cool. Again, we saw these. So, I'm going to explain this picture a little bit more and try and explain what's happening. Here we have the oxygen molecule, the oxygen atom, and it's attracted to the hydrogen atom of another water. These are called hydrogen bonds, and they're very strong. Which is actually why water is a liquid. Water has no right to be a liquid at room temperature. Yet it is because of these strong hydrogen bonds. Because it takes a lot of heat to break these bonds apart and make it into a gas. So for a gas to form, these bonds have to be broken. These ones stay. So when water turns into gas, it's still this molecule. These are just broken. And in solids, this is even tighter together, and they're in fixed positions. Conductivity is electrons being passed from one atom to another. This is way more important in metals, and we'll get to metals soon. So these are the 4 types of solids, sorry. A few of you did your research on covalent network solids. That's the last type we're getting to, and they look like this down here. But what we're doing today is this type of solid, still ionic solids. So we saw these, they form a nice crystal lattice shape. Again, we've been through all this. This is what they look like. Keep skipping through, we saw ionic bonding and electrons donated from one atom to another to form a positive cation and a negative anion. It's a very strong type of bonding, hence it's got a high melting point, because it takes a lot of energy in the form of heat to break apart these ions, to get it to melt. So, we're doing an external, meaning you need some notes in your books So if you could pause the video now, make a heading in a notebook saying ionic bonds, and copy these notes down. You can pause the video to copy the notes down. I'm not going to pause it, so just continue on when you're finished copying these down. Why notes are really important is because there's something called a forgetting curve. You've probably forgotten 50% of what you've learned yesterday based on this graph, and in 7 days' time you'll only remember 10% of what you learned today. Hence, reviewing notes is really important, because each time you review notes, again, it's just another forgetting curve, each time you review notes, it goes back to 100%, and notice that the curve of forgetting actually gets less steep each time you review your notes. This is really important for externals. Now, here's a cool new thing. Ionic solids dissolve in water. You need to be able to draw a really simple diagram of this. And if we just take a look at what's happening here, this is an ionic solid with positive cations and negative anions, and look how they're arranged. Got a negative anion surrounded by 6 positive cations in a 3D shape. Now these are water molecules here, and if we look what happens, the positive part of the water is the hydrogen, hence it's got this little positive sign here, and the negative part of the water is the oxygen, and it's got this negative charge here. It's a partial negative charge. It's not fully negative, just electrons hang out around the oxygen way more than the hydrogen. And what happens is the oxygens, because they're slightly negative, they are attracted to the positive cations, and look, this one's just getting yeeted out of here by all these water molecules. They're surrounding the ions and pulling them apart. The positive hydrogens are attracted to the negative anions. See, look, those two are the hydrogens, they're attracted to this one. And the negative oxygens are attracted to the positive cations. Okay? Next thing is ionic solids are brittle. Because they're arranged in this really neat pattern, a sharp blow to it, like with a hammer or just hitting it with your fist, that will hurt. If it's a hard crystal, a hammer would work a lot better. What happens is it makes these charges line up, and like charges repel each other. You've probably held 2 magnets together before. In one way, the magnets stick together, and if you try and turn one magnet around, it will push apart. Same thing is happening here. When these charges line up, because you hit it with a hammer with a sharp blow, they repel, and the crystal splits apart. The lattice is broken. It's still 2 solids. You've turned one solid into 2 solids, so you're not melting it, you're breaking it apart. Hit it with a hammer, like charges repel each other, and the crystal cracks. It's brittle. Here are another set of notes for you, and these will be the last notes for today, so pause the video and write these down in your books. Then, we're finished with ionic solids. That was easy. Tomorrow we'll be looking at metallic solids. These are metals. But that's all we have time for today. Thank you guys for tuning in.